All right, guys, still on top of this free energy device that I'm working on. So the last video that I made, I showed the cardboard tube, the barrel and that just didn't suit my liking. So where I work, I work for a school bus company, and they have these blower motors that constantly crap out on the low speed, and they throw these things out regularly. So I took one of them, I took it out of the cage, took it apart, made this little wooden stand, drilled the hole in the back, bolted it down, supported it, and it's pretty centered, I guess you'd say. It's much better than that cardboard tube. So I made my coil, and basically what I did is I took a piece of 1/2-inch mild steel from Tractor Supply, cut it down to 2.5 inches. I threw it in the forge, got it red hot, and then I set it aside and I just let it cool down naturally to soften it up, anneal it, so to speak. I did some research online for soft iron, and the reviews sucked. So anyway, this works. Something I want to point out, because after I made this coil, I hooked it up to my power supply and it didn't work. And I was like, it's got to work. I magnetize screwdrivers by wrapping wire around them, touching them on the positive and negative posts of batteries real quick, and you've got a magnetic screwdriver. Long story short, enameled copper. It didn't make a connection because of the enamel. So don't be Steve. Take a lighter, match, whatever, and just cook the ends a little bit to burn off the enamel so you have an actual connection and you're good to go. So this fan actually does work on the low speed setting, which is designed to operate on 12 volts. My power supply goes up to 30 volts. So you can power this up beyond 12 and it spins very fast. But that's not the point of this. The point of this is it's got 5 blades, and I put a neodymium magnet on each blade. I measured it out so that I really wanted to try and keep the balance. It's not a super great bearing in here, but the weight of the magnets actually helps with not a counterbalance, but like a flywheel. The added weight helps it to spin. So I screwed these down because somebody made a comment, I don't have to worry about getting hit in the head with a magnet or something similar like that, because I guess that meant that it's not going to work. So long story short, if I hook this up to my power supply and turn up the volts and the amps a little bit, you can see that it repels that. If you make a coil, it depends on which end that you put is your opposing end to the magnets that you're working with. And if you've got the wrong end, it's simple. Switch it the other way and you'll be fine. So this fan, as I said, will work with the power supply and the low speed wiring. There's actually 3 wires. There's a low and a high speed. There's no medium on this. So my 2 concerns are, the first is that this coil gets hot. There might be 5 just might be too much. 3 or 4, 3 might have been better. But I'm going to use, and I just got these the other day off Amazon, reed switches to trigger the coil. But I still think it's going to get hot, especially at a higher RPM where it's triggering so quickly that it's going to be on like a long time, 90% of the time. But here is what I'm thinking. So this is a fan. It generates air. I'm not going to run anything off here with belts or pulleys or anything crazy. But I can get, if I can get, the correct motor. Watch what happens. The airflow from this fan spins this little fan, and you can set things up to create a current from little DC motors. My hope is, and I get it, thermodynamics suck, but I get it, that you can't get more out than you put in. But what I'm hoping is that since this isn't connected to this, that I can use a 9-volt battery, rechargeable battery, charge it through this, and have this. I like to experiment. I studied electronics a long time ago, and as a matter of fact, because I'm an idiot, I just ordered a soldering station, a helping hand station, and capacitors, resistors, diodes, pot switches, and all kinds of crazy stuff that's going to wind up over there on that shelf, and 5 years from now I'm going to be like, oh yeah, I remember. But anyway, I'm not going to give up on this. I'm going to continue, and we'll see where it goes. And I have another super genius idea. I don't know if you've seen any of these siphon pumps that they use in ponds to irrigate their fields, but I probably shouldn't share this, but think of this. If you can actually get that to work in a small container. Long story short, I sold a house in Pennsylvania 2 years ago. The septic pump, the grinder pump, was bad. So I had the septic pumped. It was bone dry in the holding tank. I replaced the pump, filled the tank up with water with a garden hose, and just to ensure everything worked fine for the inspection. So I get a call from the realtor like 2 days later, and he says they're going to come down, do the inspection, and they want the tank dry so they can flood it and make sure it works right. And I was like, oh God, you got to be kidding. Another long story short, I took a 12-foot piece of garden hose, and the tank itself was about it was about 6 feet deep because it was over my head standing in it. And I put it to the bottom of the tank, and I used a vacuum pump, filled that hose with water, and the ground kind of, like if this was the hole in the septic tank, the ground kind of leveled out like this and then went down. But it didn't go down so far as the bottom of the tank. So when I started that siphoning effect, I swear it literally pumped that tank dry. So what I'm thinking is, if I can design, and I know use a big container vacuum, and they fill with water, so you got to have a balloon type bladder in there to pressurize it so it can't fill with water. But if you can make a recirculating in the same tank, a recirculating siphon effect, then you can run like a turbine. And yeah, I'm talking too much. Anyway, I just wanted to update y'all, and this is definitely an ongoing project. We're not giving up, and if it fails, I will certainly admit that it fails, and I'm pretty sure it's going to fail. But it doesn't matter, because I'm going to do everything that I can to make this work. And that other clown that runs all over these videos, all over YouTube, oh, the hardest part about making a free energy machine is hiding the battery. Well, I try to make this as slim as possible so you can see there's nowhere to put a battery. We'll see what happens, guys. Stay tuned, hang in there, stay warm, dry, and we'll talk soon. Take care now.